Hey guys, welcome to Unit 9, Lesson 2. Our topic today is velocity and rates of change. So I want you to get started with the warm-up. It says describe in your own words what is shown in each of the following graphs. So let's talk about the movement of these graphs in terms of increasing, decreasing, and constant. So if I was to, you can choose to trace it. If I look at the graph from left to right, it is what? Increasing from 0 to what looks like 12 here, right? So 0 to 12. Then it's constant from, or at rest we can say, constant from 12 to 15. And then from 15 onwards, it is what? Decreasing from 15 to all the way through 25. So now let's look at number 2 also. Same idea. So where is it increasing? It is increasing from 9 to 10 and then from 11 to 12. So in 2 intervals it's increasing 9 to 10 and 11 to 12, right? And then it's constant or at rest from 10 to 11 and 12 to 2, right? From 12 to 2, that's at rest. It's a horizontal slope, so that's a constant. And then it's decreasing all the way from 2 to 5. 2 to 5. So that's what is happening in these graphs. So in this lesson, we are going to be analyzing more graphs and exactly what we did for our do now, writing intervals as increasing, decreasing, constant. We're going to be writing more of those and examining our graphs. So there is some important terminology which I already wrote out that you need to know. So the most important type of rate of change in calculus has to do with that of motion. We will start with particle motion along the x-axis. Important terminology that you need to know. In discussing motion, there are 3 closely related concepts that you need to keep in mind. These are, so the first one is position. We're going to be talking a lot about the position graphs, and the velocity. These are the 2 that we're going to be discussing today. So a position of a particle is represented by either x of t or s of t. Some questions will have y of t, but that's very rarely happening. For most part, it's x of t or s of t. And then the position function represents location of a particle at time t. When we say that what's your initial time, we set t equal to 0. At the origin means your whole position graph is set equal to, or the equation is set equal to 0. Now let's talk about displacement. Displacement over an interval means how far the particle traveled from A to B, which can be found by x of b minus x of a. We will be using that a lot and just need to understand what displacement means. So let's say I travel from here to the supermarket and then I come from the supermarket back home. So if I did travel a few miles, whatever that miles is, let's say 5 miles or whatever, but if I was to talk in terms of displacement, I ended up where I started with, right? I went the same amount of distance to the supermarket and I came the same amount of distance back. So basically the displacement was 0 for that. But yes, definitely I did travel some distance. There will be miles in my car, but there was no displacement happening there. So let's talk about total distance traveled. Means sum of absolute values of the distance between turning points. So your distance is basically the absolute value between those turning points. Now let's talk about the velocity. The velocity of a particle is represented by the first derivative. V of t is equal to the derivative of your position graphs or your position function. So velocity function represents how fast position is changing. So the sign of the velocity tells you whether you're going to the left or right. If it is negative, you're going to the left, and if it's positive, you're going to the right. If your velocity is equal to 0, the particle is at rest. If your velocity is greater than 0, your particle is moving to the right. If velocity is less than 0, the particle is moving to the left. It's very, very important. You'll be asked this like quite a few times. So we need to get very good with all this vocab. And as we go along with the questions, these will make more sense. The particle changes direction whenever there's a sign change happening. So if it's going from left to right, there will be a sign change happening, right? It's going to be hitting the x-axis, or when the velocity does not exist. And the last thing that I want to talk about, speed. Whenever we say speed, we are basically asking for the numerical part of velocity. It is the absolute value of the velocity, and speed can never be negative because we said it's the absolute part. So remember, speed is always positive. We can examine particle motion graphically and analytically and numerically. So today we're going to be focusing just on the graphical aspect of it. Number 1, a graph is given to us. The graph at right shows the position s of t of a particle moving along a horizontal line. It actually tells us the graph is a position graph. Always identify your graph. So this is a position graph. So now choice A, it's asking, letter A is asking us, during what time interval is the particle moving to the left, right, justify? So the biggest question here is, if it's moving left, I remember is from our vocab is that velocity is what? Less than 0. If it's moving right is when velocity is what? Greater than 0. And we also know our velocity is what? Our first derivative of our position graph. But how do I determine that information, or how do I get the information of velocity from the position graph? Remember, velocity is less than 0 means what? Your slope is going to be negative. So where in this graph is your negative slope? That will tell us that our velocity is less than 0. So your slope is negative over this interval, which is what? 2 to 4. And your slope is positive means what? That your velocity is greater. So what would that be? Your slope is positive over this interval, 4 to 6. From 0 to 2, it is just constant, and similarly from 6 to 7. So we really didn't need to talk about that, right? It's just asking us left and right. So our right would be 4 to 6, right? So this is what you're going to be talking about. I also just want to tell you, now it says justify. This is your justification when velocity is less than 0 and when velocity is greater than 0. That's your justification. I like to do the justification first so that it helps me answer the question. So do your justifications and it will kind of guide you towards what the answer to that question will be. Do not use slope in your justification. Do not use the word slope in your justification, because you're not being very specific. Slope of what? Are you using the slope of the position graph or the velocity graph? And you end up losing points on your AP exam. So you don't want to do that, right? So your justification was more where I put the stars there. You're talking about the velocity being positive or negative, greater than 0 or less than 0, right? Simultaneously. So it's B is asking us, at what time is the particle at rest? So rest means what? Your velocity is equal to 0, right? Your v of t equal to 0, right? And you want basically, and remember your v of t, your velocity is what? Derivative of your position. So we want to find the derivative when the derivative is 0 of our position graph. So where is the derivative of 0? So your slope 0, right? So your slope is 0 at what intervals? From 0 to 2 and from 6 to 7. Okay, so C, it says during the first 6 seconds, what is the particle's displacement? Explain what this means in terms of the particle's change in position. Remember, I want to find the displacement means where I ended from where I started, right? How much did I move? So it is basically your S of 0, S of 6, that's where I ended, minus where did I start? S of 0, right? Because it said first 6 seconds. So be careful. My graph goes all the way to 7, but it just wants me to know my displacement for the first 6 seconds. So where I ended minus from where I started. So S of 6 minus S of 0, which is, so S of 6 is negative 2, right? That is, look here, it's negative 2 minus 4. S of 0 is 4, which is negative 6. What does that mean? The negative is telling me that it's moving left. The particle moved left how many units? 6 units. This is what it tells me. Explain. It's asking you to explain, so that's what it means. Part D. During the first 6 seconds, what is the particle's distance traveled? So remember, your distance traveled is basically your total distance, which is what? The absolute value of how much you traveled. It's basically the change I'm having in y-axis in each of the interval. And remember, we're not going to be counting the negative because it is the absolute value. So let's look at our intervals and be careful. The graph goes all the way till 7. It's asking us for the first 6 seconds only. So from 0 to 2, if you look at this position graph, the particle is at rest, so there's no distance being traveled. Then I look at from 2 to 3, a total distance of 4 units is being traveled, right? So that's 4. Then as we go from 3 to 4, again, you'll be like, oh, it's negative 4. No, it's the absolute value, so it's another 4 units. And then from 5 to 6 is just 2 units, right? So from, not 5, sorry, 4 to 6, that is another 2 units. So a total of how much did we travel? It's a sum of these. So it's 4 plus 4 plus 2, which is 10 inches. So part E, what is the particle's velocity at t equals 5 seconds? And then explain what this means in terms of the particle's movement. So again, this is my position graph, but I want to find the velocity at t equals 5. How do I find them? I want to find the rate at 5. So what if I find the average rate of change around it over the, so my average rate of change is what? S of B minus S of A over B minus A, right? So if I look at the line between 4 to 6, can I not find the velocity or average rate of for velocity at t equals 5, which would be S of 6 minus S of 4 over 6 minus 4. So S of 6 is what? You can go to your graph, look it up. S of 6 is negative 2 minus S of 4 is negative 4 over 2, which is what? 2 over 2, which is 1 inches per second, if I was to use the right unit. Now, remember, position was increasing and moving to the right because velocity is positive, which you could have seen it from the graph itself. So these are a few things that you can actually, without finding the answer, predict just by looking at where the graph is. So the last one, F. During what time interval is the particle speed the greatest? Velocity the greatest. So we need to be very careful with the two. Speed can never be negative. It's always positive, right? So basically I'm looking where it's moving the fastest or where it has the steepest slope. It has the steepest slope on what interval? From 2 to 4? Now the velocity is greatest where? It's a position graph. So again, how do I determine using the position graph, how do I determine my velocity? I look where my slope is positive. Where is my slope positive? Over what interval? And that would be 4 to 6. Okay, so this is what there is only one question for homework, guys, so finish that. I would also want you to study the vocab because there's a lot of new things that you learned and I want you to get very thorough with it. If you have any questions, please feel free to reach out. Good luck, guys.